Good evening everyone. I hope you are doing well. In the last video, I discussed the types of rainfall analysis and mentioned that from the next video I will discuss each subtype of rainfall analysis and explain how we can calculate them. So now I will discuss average depth of rainfall or areal average rainfall, which is subtype of area analysis. The average depth of rainfall means average rainfall for a specific area over a particular time period. So here is three main terms. One is average rainfall and another one specific area and next one time period. Here also area can vary from very small to large region. It can be a administrative unit or a natural region. A time also from minutes to hours to decades. This means that to calculate the average depth of rainfall for a particular region, we need to collect the data for a specific time period over which we want to compute the average depth of rainfall. Main question is why we calculate average or what is average. I hope you already know average is the central value that represents the set of data. Here data means rainfall of multiple stations. Let's assume you want to calculate a average rainfall of Delhi, Kolkata, or your residential village or block. If we consider this is an area and here are multiple weather stations. Let's assume here is 5 weather stations. So we will not write the rainfall for each station. We will calculate the central value or average to represent the rainfall of this area. There are three main methods to calculate this average or central value. Methods are arithmetic mean, Thyssen-Polygon, and isoidal method. So let's discuss the arithmetic mean method to calculate the average rainfall of a particular region in a specific time. This method is generally applicable for area less than 500 square kilometer. It is most effective in area where rainfall is nearly homogeneous throughout the region, because we know arithmetic mean is influenced by outlier or data variability, which we will discuss later at the end of the slides. For example, when we calculate the rainfall for a city over a specific time period, there will be less variability within the city as compared to the rainfall for an entire district or states. Therefore, this method is more suitable for a smaller region. And this is the most simplest method for depth of rainfall analysis, because this is basically based on the arithmetic average of data. And this is the formula. PAV, that means the average depth of rainfall in a particular region in a specific time. And P1 means rainfall of rain gauge station 1, P2 means rain gauge station 2, P3 means rainfall of rain gauge station 3, and up to the Pn means n number of stations, and divided by n, that means total number of stations present in a particular region. In the simple format, we can write the formula like this: n summation p divided by n. P means summation of rainfall of all stations, and here n means number of total stations. So let's calculate. Assuming that this is an area with 5 stations A, B, C, D, and E, with daily rainfall in millimeter here. These are the 5 stations and rainfall in millimeter in a day. If you want to determine the rainfall for your village or your district or any desired area or region, you need to collect the data from all the stations within that area. If you want to calculate hourly average, you have to collect the hourly data from each stations, or if you want to monthly average rainfall, so you have to collect monthly rainfall data from the stations. Now let's calculate the average depth of rainfall based on these 5 stations. So here it is, summation of 5 stations divided by 5. That means 14.56 millimeter in a day. Now let's talk about the disadvantage of this method. The disadvantage is that the outlier. I hope you know the arithmetic mean is influenced by the outlier. Let me give an example. Let's assume rainfall at these 5 stations are 2, 3, 4, 2, and 19. That means rainfall of station A is 2, B is 3, C is 4, and D is 2, and E is 19. So mean rainfall is 30, summation of all stations 30 divided by number of present 5. That means 6 millimeter. But the rainfall of four stations, that means A, B, C, D, below 6 millimeter. This means the average 6 is affected by the outlier, which is 19, the rainfall of A stations. In this way, a very low amount of rainfall can also affect the average. So before applying this method, we should check the outlier in the dataset to see whether there are any outlier or not. If there are an outlier, we should consider others methods instead of this one. Later we will discuss how to check outlier in any datasets in another video. However, for this reason, this method is applicable for a small region or a homogeneous rainfall area. Even if we found the outlier in a small region, we have to apply the others methods. From the next video, I will discuss the others method of average depth analysis.